This episode of the HVAC School Podcast is made possible by Testo and Carrier. And I have been testing out a lot of different Testo products recently. I've been using the Testo Smart Probes app. I've been using the 605 Eyes quite a bit, which is their thermohygrometer. They do a really great job of measuring temperature and relative humidity, dew point, wet bulb, dry bulb, all that. But I've really been enjoying the Testo 550, which is their simple kind of base manifold set. And what I really like about it is the combination of its functionality plus its price point, and it's also Bluetooth connected. It's truly the manifold set that I'm suggesting to my own technicians. When they buy tools, that's the one that I'm recommending to them to buy. Also, thank you to Carrier for supporting this podcast. I've worked with Carrier now for 12 years in my own business, and through the ups and downs, Carrier has taken really good care of us, and I'm really excited to see what Carrier's been up to lately. We deal with Carrier Enterprises here in Florida, and they've really treated us well. We actually are getting a new Carrier Enterprise right behind our office here in Claremont, and I'm glad to see them continuing to expand. The one thing I really do like about Carrier is how strong its distribution network is. I was talking to one of the other distributors from the South up in Georgia and in the Panhandle of Florida and some of the other states called Mingledorf's. And I'm just always impressed by the quality of distribution that Carrier brings on. Carrier, turn to the experts. Also, this episode is sponsored by the Danfoss family of apps. So Danfoss has created some really great free apps for iPhone and Android with the technician in mind. Apps like the refrigerant slider app, which is a really great PT chart type app, but it's a lot better than a chart. It's very easy to use. And the troubleshooter app and many more. You can find all the free Danfoss apps by going to danfoss.com/cool apps. That's danfoss.com/cool apps.
I don't know who you are. I don't know what you want, but I will find you. And I will regale you with the moral superiority of proper equipment sizing.
Okay, I need to make a confession. Confession time, as they say. I haven't always been the best about doing proper manual D duct sizing, okay? And when I say always, maybe a week ago. Duct sizing has not been my thing, and the reason that is because I've never done new construction, especially not residential new construction, since I started in business. And in commercial, you always have a designer who tells you what to put in, right? So you rely on them. They tell you what size ducts to put in and all that kind of thing. And then you have a test and balance contractor who comes in after you. So the reality of designing a residential duct system is not something we do often. And when we do it, it's in a retrofit application, and we do our due diligence to the best of our limited knowledge. I picked up a book recently, and this book is called Understanding Manual D for Residential Duct Systems, a companion guide to Manual D. And it's really good. I'm flipping the pages right now. That's the sound of the pages flipping. You know why? Because it's a real page turner. That's why. No, it really is it's a really, really good book. And it's got great pictures in it too. It's actually just really good. It's well written. It's got nice illustrations, and it's actually published by ACCA. It's got the big ACCA stamp right on top. So I figure when I first look at it, it's going to be a dry read. Not at all. And the writer is Mr. Jack Rise. So if you've kind of followed the Manual J, Manual D world for a while, I'm sure you've heard Jack's name. If you look up on YouTube, you'll see some of his videos there, and he's done a lot of training for ACCA. I kind of put him on par with Dan Holohan as far as the way that he speaks and the way that he writes. It's very matter of fact. There's a lot of story in it, a lot of experience. Jack's been doing this a really long time, and I found out he's a Floridian, so he doesn't actually live too far from me, or Floridian now, I guess I should say. He's a transplanted Floridian, and so I asked him to come on the podcast, and he agreed, which is weird. It's weird that people actually agree to come on this thing, but I guess there's the power of radio, as they say. So here we go. We've got Jack Rise, and actually I pointed out to him that we are both in Florida, and I said, Jack, why do you think people are so critical of people who live in Florida?
Don't they know that we are in the cyber pocket of greatness?
How do you get to be Jack Rise?
Wow. Well, I was born into the industry. My dad was a contractor, and he was a great teacher, although, like all teachers, he was limited in what he knew. He can only teach me what he did know. Nobody can teach you what they don't know. But that was a great beginning, because I would run around as a kid. You love to run around in trucks with your father when you're young and hand him tools, and learning all that stuff early on, it just got me into a mode where I realized that the more I knew, the better I was at what I did. And I think most people want to be good at what they do. And I went into Oh, God, I was 18 years on my own as a contractor, 13 years in wholesale distribution of HVAC products, and I worked for York International for 5 years. So I pretty much followed the chain of distribution from manufacturer to middleman, wholesaler to contractor to end user. So I've been very fortunate. I've had opportunities that a lot of people just don't get in the industry. I can envision many people coming in at the helper level, if you will, and then they learn to be, installation technicians and eventually service technicians, and they still don't have the opportunities that I had. I worked for very large companies at one time or another that gave me total freedom, carte blanche, to do whatever I wanted. If I wanted to go to the Little Red Schoolhouse at B&G's campuses, I'd just get in a plane and go and be gone for a week, I just had extraordinary opportunities most people don't get. And it's not like I sought it out. It's just presented itself. And I guess the only thing I was really smart about is I took advantage of it when it did present itself. I'm not the typical person. And when I talk to groups like a vocational school group or something like that, I try to remind them that there's something other than just doing service in this industry. There's a whole lot. Wholesaling, training, it goes on and on. But I've been very fortunate.
Was there anywhere along the line that was sort of an epiphany, something that came up that made you realize that you really wanted to be a trainer?
Yeah, early on. By the way, I totally rejected this. I did not want to be in this industry. The thing I have to recall, because it's in my brain right now, I have to say it, I was moving from one house to another. And my uncles, we have a very tight family, my uncles were helping me out. And I'm in the back of the truck with bed sheets and, the couch and all this stuff. And we're driving. And my Uncle Walter said to me, he said, "What are you going to do for the rest of your life?" And I was about maybe 20 years old at the time, 22, something like that. And I said, "Gee, I never thought about it. I'd just been kind of handling things as they came along, He said, "Jackie, I think you're doing it right now. You just don't realize it yet." And I came to realize later on that what I really enjoyed about the industry was training, was teaching, because I thought it did the most good. And when I was a wholesaler, I did a lot of training because I was the middleman. It was my job to add value to the product that I took from the manufacturer and passed on to the contractor. So I got heavy involved with it then. We would have training courses every week, literally every week. There was a sign-up sheet at the counter. Big company in South Jersey. A lot of money, a lot of opportunity, again, for me to do whatever I wanted to do. I had a newsletter we sent out. We had 9,000 people subscribe to it. It went out monthly. It was just a great place to work. And no matter what I was doing, when I was contracting, I wanted to be a wholesaler. And when I was working for York International, I felt more like, because I was running the New Jersey branch or running the operations manager and the technical service manager at that facility. And at that time, we were the only York distributor in the state. So that gave me a lot of opportunity to do training and, improve the knowledge. You go in the field and your tool bag is empty. How much work can you really do? If you can fill that tool bag with this kind of training, this kind of information, knowledge is power in our industry. It really is. I got to stop myself from talking. I'll go on all day.
No, I enjoy it. I enjoy it because I think a lot of people want to know the person behind the training, who, I remember when I was early on in the trade, I would go to these training classes and I would listen to trainers, and I was so in awe by all the things that these guys knew. And for me, the epiphany was I really want to be the person who understands the trade deeply, because my experience was most of the guys who I rode with, though they were really great guys and they taught me a lot about how to physically execute the work, they really didn't understand the why of what they were doing. So when I listen to you and I read what you write, you have a really clear understanding of the whys behind what we do. And so for me, it's nice to kind of know where that comes from.
Yeah, and to me, that's very important. I've been with a lot of people in the industry, as you can imagine, trainers and whatnot, and nobody knows everything, for one thing. I think it was Abraham Lincoln that said at one time that knowledge is not knowing everything. It's knowing where to find out everything. It's more about reference than it is about rote memory knowledge. And I've been been in classes with a lot of trainers that really don't understand the industry. They're essentially reading out of a textbook. In fact, reminded me, funny story, RSES, Refrigeration Service Engineer Society, is where I went, thank God, early on to learn about this industry. The very first teacher I had, I walked in my very first class, it was at night. It was at a wholesaler's second floor classroom, put that in quotes. I walked in there and sat down, didn't know anybody in the room. There were maybe 15, 20 guys there. The instructor stands up at the podium in the front of the room, and he starts reading out of the manual. And if you asked him a question, he would reread the last paragraph. That was my first instructor. So immediately I knew I could do better. But I had to tell you that. It came into my head.
Well, you see that even nowadays. You walk into a presentation that a trainer's giving. Anybody who's in the field and goes to these presentations, a lot of times it's with manufacturers or different associations. You walk into this presentation, and if the presenter starts reading the slides to you, you immediately know it's going to be a long day.
And talk about that, Brian. I mean, what do you expect? Our industry has somehow made this McDonald's fast food. When somebody says they're going to have a class on something, if it lasts more than 90 minutes, geez, I got to get to my kid's soccer game. You know, we've somehow, and I think it's the manufacturers that have done it, it's all product-specific information. It's very hard to find generalized information about refrigeration, air conditioning, whatever. It's almost like we're hiding it. The good organizations like RSES and that used to do all that kind of work. I looked at your podcasts that are available. You got a lot of good information in there. But that stuff's hard to find. If you're dealing from a carrier outlet somewhere in North Jersey or something like that, and they're going to have a class, it's going to be on a specific product and exactly how to install it and how to repair it when it goes bad. They'll just say, well, pull a 500 micron vacuum. What the hell's a 500 micron vacuum? Yeah, nobody ever explains that part to you. So what do the guys do? They go in the field, they put their service gauges on, and they see that they have 30 inches of mercury, and they figure that's 500. The width of the needle is 3,000 microns wide that they're looking at. We're doing it all wrong, and I'm sure that's not true exclusively everywhere, but as a rule, wherever I go, we're not doing it right. I go up to Denver where they should be using 540 CFM, cubic feet of air per minute for every ton of cooling capacity they have. I ask them what they use, and they tell me 400, and I try to explain it to them, and it's like looking into the eyes of a deer in the headlights, There's not enough good information out there. At least that's my opinion.
So I want to introduce the Manual D training that you do, because that's sort of the meat and potatoes that I want to talk about today. But
Sure.
What I really like about your guide, the official companion guide to the Manual D that you wrote, is that it's written in a style that I akin to the way that Dan Holohan writes. I don't know if you're familiar with Dan and his writing on hydronics.
I know Dan well. He is my hero. We had very similar paths. He was working for Wallace Ennis back in the days when I was in Bricktown working for L&H Plumbing and Heating Supplies. I was running the HVAC division. And Dan and I, we spent a lot of time talking. He gave me a lot of advice when I first went out on my own teaching full time. I think the world of Dan Holohan. In fact, if you look up hydronics in the dictionary, it says see Dan Holohan's page on the opposite page,
Right. The way you write is so similar to the way that Dan writes, in that when you get something that's essentially the official companion guide from ACCA, you sit down and you open it up and you expect it's going to be a lot of really super boring, just mathematical equations with very little real life examples. But that's not how you write at all. You write very practically, very openly, and even in some cases critically of things that go on in the industry, which isn't what you would expect. And that's the same way that Dan writes. It's super engaging, which is why I knew you would be good on the podcast. Your book is one that I could probably just sit down and read into the mic and would be entertaining and interesting to the people who listen. Not that I would do that, of course, patent pending, copyright, ACCA and Jack Rice Industries. But
But that's very nice of you to say. Thank you.
Yeah, it's really good stuff. So I want to just kind of jump into that then and start with asking the general broad question. What inspired you to write that in the first place? What was it that caused you to actually sit down and put fingers to keyboard and write that out?
Absolutely exhausting frustration. ACCA sends me to a lot of places. I have a lot of people all over the country that call me in from time to time to do training. And what is contained within the pages of the, I'm going to call it the unabridged edition of Manual D, is absolutely wonderful engineering. Hank Ruthkowski is the single most brilliant man I have ever met in my life. I will sit at his feet and learn until the day I die. His perspective of this industry is so refreshing. Every time I'm in a class with him, he blows my mind. He'll say something or do something that'll cause me to look at a subject matter that is so different from any other way I ever looked at that subject. What caused me to write it? ACCA came to me and they said, we want you to write a couple of books. They said 3 books, J, D, and S. And I said, well, why do you want a book? And they said, well, people are studying for exams. And, although the CDs are good and all that, but they have to keep backing up a CD to get ready for an exam. That's hard to do. That's not comfortable. So if you write a book and they can open up to a page and study a certain area or whatever, then that'll be beneficial. So I did it reluctantly. And once they gave me the charge to do that, it just took on a whole new dimension. That's where I got into remembering everything when I was in Denver, when I was in Phoenix, and I'll go to a dry portion of Arizona and somebody will start talking to me about having moisture in their pans, It just, there's so much information out there. And people insisting, when I pick my equipment, I go right to AHRI and pick 70-30 combinations they publish. You're in the desert, man. You're 4,000 feet in the air. You don't have moisture in the air. If you do, turn the sprinklers off on your lawn because it shouldn't be. And, I just got so frustrated with every time when I give a Manual D class, the first thing I have to do is deprogram the thinking of everyone in the class if they've been in the industry for any amount of time. They know point 1 is how you design a duct system. That's the friction rate. They know there's 400 CFM in a ton. They know there's 12,000 BTUs per ton. That's ingrained into their memory. And that's about the extent of their knowledge. So it's a lot of undoing. But the true reason I wrote it, I was asked to. And once I got that charge, that you go do this, man, it just turned a lot of stuff loose in my brain. So if the book seems a little erratic or something, that's on purpose. I'm told I explain things well. And that to me is baffling because I really don't think I do. I'm constantly trying to find words in my head. But if I did that well, if I explained how Manual D works well, then I'm very happy with what I produce, whether people like it or not. It's a good explanation, I think.
What you did really well is you thought like a technician thinks, and you intentionally deprogrammed. You didn't just build up in the way that an engineer would build up, from the simple building blocks all the way up. You first were intentional about actually battling the false thinking that a technician is going to come to the table with in the first place. I mean, you start right off at the beginning, just debunking some myths. So let's start there, because the first thing you brought up was the 0.1 static. That's how you design a duct system, by 0.1 static. So let's talk about when a technician says that, what are they saying, first off, and why is it totally wrong?
Okay, they're saying it because that's what they were taught. That's what I was taught. My dad was more in the hydronic side of heating. He also had a plumbing license, so he favored the plumbing and heating end of the HVAC business. So I can remember, 16, 17 years old, and I said, Pop, why do we use 24 by 8 duct in that Mrs. Smith's job the other day? How come we didn't use a different size? You get to an age where you start to question things, And he said, well, here, you went to high school, you can read. Look, it says right here, somebody unfortunately wrote right on the duct calculator, set your volume CFM opposite 0.1 in a duct calculator. And that's all you have to do. Oh, hell, man, I was empowered. By the way, you know how he taught me to do, Pop, why did we use an 80,000 BTU furnace in Mrs. Jones yesterday? We got 100,000, 120 in stock. How come we used 80? Oh, easy here. Length times width times ceiling height. He didn't know that was volume. God bless my father. He quit school in the 11th grade, joined the Navy, went off to fight in World War II. So he had a limited education. So he would always say, length times width times ceiling height times 8. Wow, that's all you got to do? Sure. Okay, how come we use the 2.5-ton cooling unit? Length times width times ceiling height times 3. Well, I took that form of load calculation and good old 0.1 into the field, took on homes my father would never take on, and almost lost my shorts until, thank God, I had other mentors that pushed me in the right direction. There is so much misinformation out there. And what do we do as recipients of that information? We take it and run with it because it's easy. We want the path of least resistance. Friction rate is a pain in the neck. First of all, it's not static pressure. Static pressure is simply taking a magnehelic or a manometer, an incline manometer, drill a hole in the duct system, put a static pressure tip in there, and read pressure. Static pressure in the case of a static pressure tip. If you put a regular probe in there, you're just going to read total pressure. But that's all it is. It's a point in time. It would be no different than me taking a water gauge, putting it on a water pipe and saying, I got 55 pounds pressure here. That's good. I don't need to increase the pressure. I don't need something to reduce the pressure. I have a good, steady 55 pounds. But that's all it tells you. And it's no different in our system. When we put a static pressure tip in the system and we see that we have 0.25 or something on the supply side, it's only telling us what the pressure is in that system at that point in time. If you want to know what the friction rate, the pressure drop per 100 feet of equivalent duct is, then you have to do the calculation. And the friction rate is equal to the available static that you have left over after you've discounted your coil, the pressure drop across your coil, your air filter, UV lights, whatever you have, the available static times 100 because it's pressure drop per 100 feet of equivalent duct divided by the total effective length of the system. That's a little more difficult than just putting 1200 CFM opposite 0.1 on a duct calculator. But the friction rate you're going to use to enter a duct calculator, I can tell you from 45, 50 years of experience of doing it by hand, is never going to be 0.1. I think twice in my life I ended up in 0.1. It's going to be somewhere between 0.06 and 0.18. That's the ACCA wedge, which is, I believe, the cause of the misunderstanding, the myth involved with 0.1. When you teach Manual D, at some point in time, you have to discuss available static pressure versus total effective length. And that is a graph that ACCA created. And they say on the graph that if you have a friction rate between 0.06 and 1.8, 0.06 and 0.18, then you have a good duct system. If your friction rate is less than 0.06, you're not going to have good airflow. It's going to be very light. You're going to have to increase the speed of the fan, get a bigger speed. You got to do something different. If it's greater than 0.18, you're going to have noise. So fall nicely somewhere between 0.06 and 0.18. What's right in the middle? 0.12. Round it up, 0.1. That and the fact that, for instance, when I teach Manual Q, commercial duct system design, you tell the students, assign 0.1 to supply ducts, assign 0.08 to return ducts. And then, because you treat it so differently, the way you do the calculations in commercial compared to residential, for instance, when I'm doing a commercial load, the assumption is, I'm using Manual Q, the assumption is I can go out and buy any blower I want, any air handler, whatever, okay? So I'm not restricted to 7 sizes. When I'm in the commercial size, I got 7 choices, 1.5, 2, 2.5, 3, 3.5, 4, and 5. Pick one. And by the way, they're all rated at high speed, half-inch external static pressure, right? And by the way, if you've got a blower and a coil, you ain't never, ever going to have 0.5-inch external static pressure unless you have 2 feet of total duct length, all right? It's just simply not possible. The coils today are running 0.3 and higher. The W coils, the N coils, they start at 0.45 and go up. There's just no way you're going to end up in the 0.5 column. So That's a whole nother issue. When I'm doing commercial work, I'll assign 0.1 to the duct system on the supply side, 0.8 on the return side. But now I'm going to treat it differently. I'm going to calculate every elbow, every fitting in my duct run, and I'm going to assign it a pressure drop in inches of water column. And then at the end of the day, I'm going to add up all those pressure drops and go out and buy a commercial blower that can overcome that and still deliver my volume of air. So I'll get on the phone to a manufacturer. Hey, I need a 20,000 cubic foot blower fan. Throw in a 2.5 million BTU steam coil. I need a 6x6 footprint, and it has to overcome 5 inches of external static pressure. How much? All right, you shop it around, you get the best price, and then you order the product. It's very simple, all right? It's not hard. Residential, can't do that. You only got 7 sizes, and they're all rated at 1/2 inch. So you can't just look at an elbow and say, all right, that has a 0.0067 pressure drop across it. You have to determine what the equivalent length of that is. And then you're going to add those equivalent lengths for each fitting into the total measured length. And then at the end of the day, you're going to have a certain distance you're going to use called total effective length that you're going to divide into the available static from that blower you chose times 100. And that will give you the friction rate that you're going to use to enter the duct calculator with, or friction charts in the back of Manual D, whatever, however you do it. Duct calculators are much easier to use. You'll go blind and start developing facial pimple complex trying to read the close lines on a friction chart in the back of Manual D. But that's the procedure, okay? You can cheat all you want. Most of the jobs I go on in the real world, somebody's cheated. If I go up to an existing system and I measure the duct and it's 24 by 8, and I put that on my duct calculator and I see that opposite 0.1 is the volume of air that they're trying to handle there, I know without ever doing anything else that somebody just used 0.1. And there's nothing wrong with duct calculators, providing you apply them as you should. But there's a whole lot wrong with people that write things on very good duct calculators that destroy them. Write things like, this is your setting, or recommended residential setting, that kind of thing.
I'm actually processing some of this as you're talking, and I'm thinking about ways to think about this for somebody who has never thought about this before. First off, I guess, the total effective length. Mm-hmm. That's the total length to the furthest point, including all of the fittings that are in that particular length, correct?
Yeah, it's not necessarily the furthest. It's the supply outlet with the greatest resistance to airflow and the return inlet with the greatest resistance to airflow. It's not always the furthest, but in most cases, most balanced systems, if you have equity in a system, the branches are all within 10 feet of each other, it's probably going to be one of the longest, but it's the one with the greatest resistance to airflow. And that's called, by the way, the critical path. Because what Manual D teaches is an equal friction method. That's why you're only looking for the worst case scenario. The assumption is if you can get air from the inlet with the highest resistance to airflow to the outlet with the highest resistance to airflow, then you can easily get air to the ones in between. So what Manual D teaches is to calculate that run, take that friction rate, and apply it to all the runs in the system.
Got it. And then that still is relying on, in that type of setup, you do still need to use balancing dampers.
Absolutely correct. In a properly designed system, there's only going to be one damper that's wide open, and that's going to be the one that was the one with the greatest resistance to airflow. All the others will have to be controlled. By the way, you can take the equal friction method and modify it to what they call a modified equal friction method. And that's where you calculate a separate friction rate for every single branch runout. The disadvantage of that is that it's time consuming. I mean, it takes a couple hours to do a simple system because you have to do what you did for the longest run for every single branch run. And that can get very time consuming and boring, and you're going to start making mistakes. The great thing today is the tools we have, computers. They work at the speed of light. And, you can make a computer giggle by giving it that much math to do. It's a wonderful tool. And shame on you if you're not using the tools. I use Wrightsoft. I think it's the best program out there. It's easy to use. It follows Manual J, Manual D to the letter. The definitions, the pictures, everything are word for word the same. So there's no loss in accuracy, no loss in the technology, the science we're using to calculate loads and lay duct systems out. So they give you an option for a modified equal friction method. And that way your duct sizing becomes more and more precise. You'll see 4-inch, 5-inch, 6-inch, 7-inch branch lines on the same job you're doing.
Okay, so the technician out there who's listening to this and saying, but Jack, how do I control the face velocity on my actual diffusers then? If I have this type of setup, isn't that going to be all over the place? What do you say to that?
Oh, sure it is. And that is absolutely critical. If you don't control the face velocity on a register, you have no control over whether the air in the room is going to mix or not. Remember, returns don't do anything in a room. They have zero effect on air movement in a room. It's the supply outlets that cause the air in a room to move. If I have 100 CFM coming out of a sidewall register, it will cause 1,000 to 2,000 cubic feet of air in that room, secondary air. And, the primary air is the airstream coming out of the register. It will cause 10 to 20 times the amount of that primary air to move into the secondary airstream. It's an induction thing. The primary air coming out of the register is at such high velocity, it creates a hole in the air. And the air that surrounds that primary airstream is sucked in, literally, to that primary airstream. Okay? That's what causes air to move in a room. The return grills only have an effective area of maybe 30 to 36 inches from the face of the register. Hold a candle. Go find the ugliest, noisiest, greasiest, suckingest return you can find. Get 3 feet away from it. Hold a candle straight up, and the light on that candle won't move unless there's primary air blowing on it. The closer you get to that, the more that light on that candle will be forced into the return grill. If a high return grill could suck cold air off of a floor, or if a low grill could suck heat off of the ceiling, it would literally have to be strong enough to pull your clothing off as you walk by it. And we simply don't have blowers in the residential industry that can do that.
Knowing some of my technician friends, they might want to use that clothes-sucking technology in certain applications, but I guess we'll leave that for another time.
Yeah.
And so when technicians talk about, because the way that they tend to talk about it would be, they'll talk about throw, but they're not thinking so much about the fact that secondary air is being drawn in. And one interesting thing that I've heard for years, but it just never really clicked with me, is when you see supply air vents that have the dirt that accumulates around them, a lot of what's going on there is that secondary air is being drawn in against that ceiling surface and then in turn causing those dirty streaks on the ceiling, which is just sort of visual evidence of what we're talking about.
That's exactly right. I'll call them the uninitiated will go into a building like that and say, oh, you need your ducts cleaned. Has nothing to do with the ducts needing cleaning. If the ducts needed cleaning and it had that kind of dust inside of it, it would be attaching to your furniture somewhere. That's called streaking, and the only thing it causes that is the secondary air being pulled into the primary airstream. It's no different than being in a shower, and the water stream comes out and the shower curtains want to pull in. It's the exact same effect. Mother Nature doesn't like imbalance. Mother Nature wants balance. So if you have a high positive pressure, negative pressure is going to seek it out, or it will seek the negative pressure out, I should say. All right. High pressure goes to low pressure. High temperature goes to low temperature. Hot goes to cold, because hot has more energy than cold does. The greater will always go to the lesser until they are both equal.
Which brings up the next thing that I wanted to talk about, because you address this specifically in your book, is the differences in trunk and branch design velocities.
Yeah.
So can you talk about that for a second?
Yeah. First of all, if you don't have a difference, you have no control over where the air is going to go. I mean, it could stay in the trunk duct. It could go to the branch outlet. You have no idea. You have to create a difference. And essentially, when you create a velocity pressure difference, you're creating a reason for the air to go from the high pressure area to the low pressure area. So your high pressure is inside the trunk. You want to keep the trunk somewhere between 700 and 900 feet per minute. And by the way, if You want air to move out of a duct, you have to create a difference for that. And you do that by creating the duct a given size for a given volume. And remember, this is all about control. You can have the same velocity in the trunk and in the branch, but again, you lost control. Now you really don't know where the air is going to go. It's an uncontrolled airflow, and that can lead to huge problems. Remember, when people say they don't have enough heating or enough cooling, they're saying they don't have enough airflow, all right? Because the only way the BTUs get there is it rides on the back of the volume, the cubic feet of air. If you need more BTUs in a given area, you need more CFM in a given area. The sensible heat equation says it all. CFM is equal to the sensible BTUs divided by 1.1 times the temperature difference times the altitude correction factor if you have one. But heat gets there with more air. Cooling gets there with more cooling air, more cooling CFM. I forgot the question. What the heck were we talking about?
We were talking something about air conditioning. It was something related to HVAC, ACCA, Manual D. No, we were talking about controlling the duct velocity in the trunk. Yes, and yeah.
Yeah, ideally, 700 to 900 feet per minute in the trunk duct. Trunk duct velocity is very important. You can screw around a lot with the branch velocities by changing the registers and grills. But trunk velocity is very important. If you drop below 700 feet per minute in a trunk, then you're approaching branch velocity, which ideally, again, would be somewhere between 400 and 600 feet per minute. And again, if you have the same velocity, air is not going to be controlled, all right? It's going to go where it wants to go. It'll take the path of least resistance always. If you go above 900 feet per minute in the trunk duct, then you're going to have noise. Noise is going to be transferred to the branch duct, and that will be transferred to the environment. And when we design duct systems, the whole idea is to make people as comfortable as possible, and nobody wants a noisy duct system. But that main trunk duct, I don't care whether it's the first of a 3 or 4 reducing trunk ducts, or it's just a splicer box, the junction box for a flex duct system. It has to be sized properly. And you talk about nightmares, that's where a lot of that dirty word I just mentioned, flex duct, gets involved. I've seen absolute abortions in attics. If I go to an attic anywhere in Florida, I can expect to see what looks like an explosion in a flexible duct factory. It's so poorly installed, crimping, binding, compression, it's a nightmare. But yeah, 700 to 900 feet per minute in the trunk, 4 to 6 in the branch line, ideally, but you have a lot of latitude in the branch line. In fact, Hank does it, and I think I repeated it in my book. I can bring a 12-inch round duct to a 4x10 floor register. 4x10 to 12-inch round 90-degree boot is not on everyone's shelf. You're going to have to make that. But that can work if I properly control the volume in that 12-inch round duct to be whatever it should be, 100, 110 CFM, and I pick the right register. Because remember, I have to have good face velocity. Doesn't matter what's in the branch line. Doesn't matter what's in the trunk line. I have to have good face velocity at the register to cause the air in the room to move. And I create that face velocity by choosing the right size register and locating it where it can do the best work.
And so just very simply, when it comes to register selection, you're wanting to keep your velocity to the point that you're inducing in secondary air, but you want to keep the velocity low enough that you're not creating a bunch of noise and discomfort from having extremely high velocity.
Exactly right. That would be the extremes. On one end, make sure you can cause air to mix in the room. On the other end, make sure you don't create a disturbance.
And when you think about commercial, very, very large spaces, you'll have tremendous face velocities in some cases. You know, you'll be sitting in a church or something, and you'll be sitting there, and you'll get hit in the face with this stream of air that's coming from, 30 feet away. And it makes sense that you would do that because you have so much more air that you need to mix. So it makes sense that the velocity, could be greater.
Yeah, absolutely right. But remember, rule number 1 is don't blow air on people. It makes them angry. 70-degree air, blow in your hand very lightly. It's warm, Same 98.6. That time, gave me a chill. And I'm sitting in a 70-degree room. So, don't blow air on people. Rule number 1. Rule number 2, the more outlets you have, the more comfortable the occupants are. If somebody is blowing air on you in a church, they didn't understand distribution.
True. I'm just imagining myself like teaching my 4 or 5-year-old son the life lessons, and I sit down and I say, son, rule number 1, Jack Rice taught me this. Don't blow air on people. He's going to give me a weird look, but...
You're terrible. Talk to your son. Teach him.
Teach him the ways that I learned from Jack.
Yep. Even if it's
right.
wrong.
Just so long as I'm teaching him something. That's the important part.
Right.
All right, so we're going to take a quick break for our tooltip corner here. One thing that you may have noticed if you measure airflow is that measuring CFM is kind of hard to do accurately. I mean, you can do it in some fairly accurate ways. A lot of guys have talked about the heat rise calculation for the entire equipment, and that's a tricky thing to get really accurate. And then sometimes you can use the fan tables for a particular blower, but then that's especially tricky if the unit's older, because if the blower is dirty at all, then that's going to affect your fan tables. If your coil's dirty, if you have a fan coil, then that's going to affect it. So it's just tricky. It's tricky to get actual CFM. I mean, you can use a pitot tube and then take the area of a duct and measure the CFM, but that's tricky. And so what a lot of people rely on is using an anemometer, an actual vane anemometer, and using the timed average method and kind of painting the vent in order to measure the airflow output. Either, I shouldn't say just output, but either the air coming out or the air going into return in CFM. And that can work, but the challenge there is you have to know the K factor, AK factor, the area factor for the vent in order to know how many CFM are actually being produced, what the open area of that vent is, and that can be tricky at times. But the one thing that's not tricky to do with a vane anemometer is to measure the velocity. And so when Jack's talking about having the proper velocity, the actual face velocity of a vent, you can do that fairly easy with the vane anemometer, and you can do that with the timed average method. It's actually really easy to do with the Testo 410i. You can paint the entire outlet, vent, and register, whatever you want to call it. I've always traditionally called them vents, but Jack calls them registers. So I'm going to go with Jack and call them a register. Paint the entire register and see what the average feet per minute output is, and then that will tell you whether or not you are going to be entraining the right amount of air, mixing the air in the space or not. And so when Jack talks about that concept of getting the proper face velocity, that's an easy thing for you to measure in the field. Even if you don't know exactly what the CFM is going to be because you don't know the AK factor on the vent, you can darn sure know, as they say, what the feet per minute is coming out of that vent. So Testo makes the 410i, which is part of the Smart Probes kit, and that makes it really easy to do the timed average method. But even a better product as far as accuracy is a large vane anemometer, the Testo 417, which I've used quite a bit, and you can do the timed average method within the actual device itself on the Testo 417. So if you do not have a vane anemometer on your truck, I would consider getting it, because it's a really good way to make sure that you have the proper face velocity on your registers. So one other thing that I wanted to mention that I haven't mentioned in a couple episodes is that you can get the best quality tools, all the different tools that I mentioned here on the podcast, from TruTechTools.com. That's TRU techtools.com. Use the offer code GETSchooled, all one word, at checkout to get a great discount. And I recommend True Tech Tools with absolutely no reservations. They're great people, and I think you'll be really, really happy with the products that you get. And then if you ever need support, they're there to help you. Both Bill and Eric, I've met both of them. I've worked with both of them. If you do end up at True Tech Tools buying some tools, just let them know that I sent you. All right, back to Jack Rise. All right, so I want to ask this question because I think this probably is coming up in some people's minds, is that when you talk about available static, so the static that you have left over for what the system can handle, essentially, that you've arbitrarily decided because, like you already stated, if it's designed for 0.5, you pretty much out of the box are already kind of screwed. You're not going to have 0.5. So now you say, okay, well, 0.7, so I have 0.2 of available static. But in certain circumstances, couldn't you have situations based on the filter that's chosen and some other design elements that you don't have control over, at which you have such low available static that your duct velocities are now going to be below the desired range? Does that question make sense?
Absolutely does. And that's typically what you find in existing systems that weren't properly designed. you got to have a place to go. This all goes back to picking the right size blower. Remember what the available static is. You've picked a blower. Let's say I'll use the example in the book. I need 1,200 cubic feet of air, and I'm picking the blower out of the 0.8 column, not the 0.5 column, because I'm never going to be there. I'm never going to be in 6. I'm just trying out 0.8 to see how it works. I might have to go to 0.9. I might have to go to 1.0. And not all manufacturers allow their furnace blowers to do that. Most of them cut off at 0.8. It's a liability issue, a fire liability issue. So if I pick it at 0.8 and I've got a coil that wet is 0.3 pressure drop across it, I subtract 0.3 from 0.8, I'm left with 0.5 as my available. Oh, wait a minute. I got a media filter in there, a 5-inch filter with a 0.25 drop. Now I subtract that from my 0.5, I'm left with 0.25. That may be my available static pressure. Multiply that by 100, divided by the total equivalent length, and if I'm not between 0.06 and 0.18, I got a problem. And I won't be if my available static is below 0.4. This is something I've learned, and I don't have a rule for it. It's just doing thousands and thousands of jobs by hand in the old days and with computers later on, that I noticed that if my available static is not at 0.4, I'm not going to end up in the 0.6 to 1.8 ACCA wedge that I need to be. So what do you do at this point? Well, I picked a blower that was 0.8. I could get a blower that would give me 1,200 CFM against 1.0, and that would bring me back up to 0.45 now. I'd be in good shape. Or I can take the media filter out. That had 2.5. And I could put in a disposable filter for 0.05, something like that, and get back in the ballpark. That's the process of choosing a blower and ending up with a friction rate that's acceptable.
I think this is exactly what we're pointing at. And just so you're aware, I don't know if you know this, but I'm in Orlando.
Oh.
You're in the Tampa area, right?
I am. I'm in Tampa, yeah.
Okay, so I've essentially spent my entire career working with A, fan coils.
Yep.
Very few furnaces. And then B, flex and board systems. Mm-hmm. And so you can imagine how screwed up my brain is, because when you say selecting a blower, I'm like, well, how do you select a blower on a fan coil? You have what you have. You're pretty much stuck.
You're exactly right. You have a whole different set of circumstances when you're talking about fan coil one-piece units. You don't get to pick the blower. What you have to make sure in the environment you're working in is that you are, in fact, in the 0.5 column, and you should well be in that 0.5 column. I mean, external static pressure, when you've already included the pressure drop of the evaporator in the tables they give you for airflow, there's no reason to ever be outside of that 0.5 column. You might find yourself in the 0.4, 0.3 in some cases. A simple spider system that's done well, you're going to end up somewhere around 0.3.
Right. That is true. On the systems that we install, where we're actually designing it, with some thoughtfulness, probably not with the level that you prescribe. Well, at least not right now. Tomorrow it will be, of course, because I'm going to listen to every piece of advice you give. I'm that type of compliant, Jack. I'm sure you can tell that already.
Oh, yeah.
Yeah, absolutely. So when we install systems with properly designed duct systems with fan coils, you're right. In general, we're going to have 0.4 to deal with. So really is no excuse. But in many cases, we're coming up to systems that already kind of have issues, that we're already dealing with in the retrofit side of things, which is a different consideration altogether. So let me ask that question, because, you having all this knowledge and having designed all these systems, you now live in Florida. You move into your first house in Florida and you look at this duct system. What do you do to a system that's already existing that has these issues in place? What would your approach be if you were a contractor in this market where there are all these flex and board systems that haven't been designed with anything other than 0.1 in mind? What's the approach?
Well, the easy thing to do is what I did when I moved down here and got in this house. And by the way, the only reason I bought this house, it was next door to my daughter, who was starting to have babies. And my wife she didn't care what we had to do. We were going to live next door to her. So, and fortunately, we were both near retirement. But what I did was just rip everything out and start all over again. It was so convoluted and such a terrible mess. It was really poor. It's a tract development. Every house was done exactly the same way, regardless of what direction the wind is faced. A typical day here in Florida, in the summertime is 91, 92, 93 where we live. Where you are, it's a lot hotter. And the unit would run all day and not satisfy the load. Somewhere 2, 3 o'clock in the morning, it would shut off for the first time. It was charged properly. Airflow was as good as it could be under the circumstances, with the fiberglass ductboard box and 50 feet of flex thrown in every other direction. It was undersized. That's the other problem you're going to find. Now, what I find generally in the field, regardless of the climate I'm in, if I'm in New Jersey or in Florida, it doesn't matter. What I'm finding is that if it's an overhead, the duct system is usually larger than it needs to be because they use 0.1. And when it's a furnace coil combination, basement, crawl space, whatever, it's way too small, the ductwork, because they use 0.1. So you have a lot of latitude, especially existing systems. I would look very carefully at the flex duct. Make sure you understand, Appendix 3, I think, in Manual D, about compression and sag and things like that can really, when it comes to flex duct, dramatically affect the airflow. I had a little routine I used to do when I worked at Air Group in New Jersey. I was hired to train everybody in the company. And I would be with the installation technician on a job, a new guy that I wanted to see how he was doing. And we would have, say, a 3-ton air handler and a box with a big, maybe 30 by 30, 30 by 24 return grill. We would have a 16, 18-inch flex duct coming off of that box where the grill is in the ceiling. I'm in an attic. And that would attach to the return plume. And of course, it would sag, even if it was 6 or 8 feet long, because of the weight of that mass, that flex duct. So I would hook up a magnehelic, put, the negative probe in the return facing the direction of airflow, the supply, the positive probe in the supply facing the airflow. I would start the unit up, and then I would hold the bottom of the flex duct, and I would push it up so that it made a nice 90-degree angle, a nice smooth turn. And the drop off of pressure, it would go from like 0.5, 0.6 down to 0.02, 0.03, something like that. It was extraordinary. But it burnt into the brain of that new guy how important it was to have everything at right angles, everything straight and plumb and vertical. And I would just move it up and down. And we used the magnehelics, the dial gauge and an analog scale would just go back and forth as I moved it up and down. It's a great teacher, but flex duct, look for compression, look for sag. I can tell you just from memory, I've taught it so many times, that if you take a piece of 25-foot flex duct, uncut, and you put it into a 20-foot span, that's 25% compression. And the maximum compression allowed by the Air Diffusion Council, the ADC, the people that write the Bible for installing flex duct, the maximum is 4%. And I know everybody, including myself, won't cut 5 feet off of a 25-foot piece of flex. You're just going to put it in there. And that slight amount of compression you're creating over a 20-foot span is 25% compression. And 4% is the maximum. If you go beyond 4%, we have no idea what kind of airflow you're going to have. I can guarantee you this, it'll be unreliable, and it won't be what you think it's going to be. It will be significantly less. So pay very good attention to flex. Make sure those lines are straight, they're pulled, they're taut, as few turns as possible. A lot of times you can just get rid of a poor installation by cutting excess length out of a job and dramatically improve the airflow.
And that's actually a good piece of advice, really. I mean, that's not typically how we look at these problems. We look at a system that has high supply static, high return static, and we say, well, the duct's undersized. But maybe in a lot of cases, if we're not taking into account what we would consider to be very small changes, we would look at a duct system and say, sure, maybe it's a little compressed here, it's a little sagging there, but that's not the problem. The problem is the size is too small. Yeah. And so we put in a bigger size, and that does fix it, but we're still not really fixing the problem. We're just fixing a problem.
Yeah, you're treating the symptoms, not the cause. And
that's interesting, yeah.
Yeah, believe me, flexible duct, it's a wonderful product. It's pre-insulated. It saves labor. I found that it was better for me, my company at the time, and all we did was custom work, to use plain round 30-gauge metal and just use insulation sleeves. It was actually cheaper for us to do it with 30-gauge than it was to use flex duct because it was too much trouble to do it with flex duct. Everything had to be tight, and so you had to pull it. You're supposed to, when you open a box of flex, hold it, pull it tight for 60 seconds with 25-pound foot. If you rolled up in a job and there was two of your guys standing there with a piece of 25-foot flex, each one of them holding it and not doing anything else for 60 seconds, you'd fire them both. And even if you instructed them to do that, the minute you turn your back, they probably wouldn't do it because it would seem like it was unnecessary, superfluous for one reason or another. There's a lot of problems with flex duct. There really is. And it's a good product, but we abuse it. I'm old enough to remember flex duct when it first came out. Richard McGarry, the guy, in fact, in the front of my Manual D that I memorialized, Richard came to me one day. I was working in Atlantic Plumbing Supply in Long Branch, New Jersey, and he brings in this box, and it was, maybe 8 or 10 inches in diameter, square box, and it was about 5-6 foot long, and he pulled this thing out, and I said, "My God, Richard, what is that?" He said, "It's a new product we got. It's called flexible duct." It came in 7-foot lengths. There was a male and a female metal end, a crimped end and a non-crimped end, attached right to the coil inside. It had 35 millimeter was the liner film, and it was insulated. And I said, "Look at this. What do you do with this thing?" He said, "Well, guys are putting it on the end of runs, and, it's easier than putting a bunch of elbows together." I thought, wow, then I looked inside and I saw the corrugation. And I had just been in a class about gas whips and the corrugation, the high resistance they offer, and how you have to upsize it. Maybe if you're bringing a 1/2-inch line, you need a 3/4 whip just because of the pressure drop associated with the corrugation. And I thought, boy, this must really add to airflow. I said, "Do you have any sheets on it?" He said, "Yeah, look here." And I said, "Holy Christ, look at that. Look at the friction rate associated with this just on 7 feet." He said, "Yeah, why do you think they make it in 7-foot lengths?" 2 months later, 25-foot lengths plain end. That's what our industry does, is something that, the path of least resistance, man. Anyway, I don't want to beat up on flex duct. It's a good product. It's just poorly handled.
Okay, so I have to ask this question. Since you tore out your duct system and put in a new one, what do you advise for takeoffs? Because that's another huge challenge that we have. We use these tab collar takeoffs. Mm-hmm. Even on a properly designed system, it seems like a really poor design. So what do you recommend in a residential system for takeoffs on a flex and board system?
Yeah, I was a qualified fabricator for Johns Manville for about 8 years, too, so I'm very familiar with flexible duct. We had a tape sealing machine, in the shop, the whole 9 yards. But I use plain tabbed flat A collars with the damper built into the collar. Because when I start closing that damper off for balancing, it's going to create turbulence, and turbulence is noise. I want that noise to stay in the trunk duct, not transmit to the branch line. So I buy the flat A collars with the damper built into them.
Yeah, that's pretty much the same thing we do. I just was curious if there's...
there's a better takeoff. You can get a wide mouth branch or an easement. They're going to reduce your effective length, by 10 or 20 feet. But there's only one of those in each equivalent length calculation. There's only one critical pass, so there's only one takeoff and one return takeoff. So it's not going to affect your job. Don't spend a lot of money on wide mouth branches unless you're trying to fix up an existing job that has poor airflow.
Yeah, exactly. If you have an issue with your equivalent length that you are needing to reduce it in order to meet an existing requirement, then I guess it makes sense. But yeah, it's interesting how much of this has changed. And this has been a real journey for me of thinking about this differently. Starting off with, I worked for a very large contractor. You probably see houses near where you live that were installed by this contractor. Mm-hmm. And I remember one time sitting in a manager meeting with the owner and the operations manager, and they were sitting there talking about the design department and how much, I think the exact quote was, they were designing everything by Manual D, but a good old trained ductulator works better than that anyway. I think it was, wow. was the quote that was used there. Well, and I think a lot of that may have been that if you're using Manual D even, but you're executing the duct system poorly, meaning you're not actually executing a flex system the way that you're supposed to, then you're not going to get the result that Manual D is telling you.
Sure, exactly right. You get what you pay for in this industry. There's no shortcuts. There really isn't. Everybody's looking to save money, and they forget about comfort. And you know what? It's hard to screw up an overhead. There are guys in this industry, knuckle-dragging monosyllabic Neanderthals that work in the Florida installation divisions of many companies that shouldn't be anywhere in the same zip code. But yet they get away with it because A, they're typically oversizing the blower, length times width times ceiling height times 3. That's not real accurate. And they, the ducts at 0.1 are most of the time going to be too large for that system. So they get away with it. The problem is if they did everything correctly, installed the flex duct the way they were supposed to, they'd have an abundance of airflow. But they don't because they throw it. They coil it up. They leave it in bags. I know a guy, I can't say his name, one of the biggest contractors in the state of New Jersey. I spent most of my career up north in a 4-season climate. And he never allows his guys to take the flex out of the box. 25-foot length of flex in a box. You open one end, throw it on the ceiling of the attic. One end goes to the takeoff. The other end goes to the outlet, wherever it is, ceiling, whatever. And that's it. And he leaves. I said, why do you do that? He said, it's neater that way. When people come up here to store things, it looks like a nice, neat job. I mean, what he did to compression, I can't imagine. I can imagine how bad the airflow is because there was nothing but complaints on that job about airflow. Well, the complaints were typically it was too strong or they didn't have enough heating and cooling, which is, again, the same as saying you don't have enough airflow. But yeah, it's all over the place. It is a shame. And I don't mean to point out the Florida contractors. It's just that I'm here and I'm seeing a lot of it now, and it's pretty bad. And yet we'll do a manual J or a manual D class through somebody like ACCA Florida, and we're dealing with a whole district, and you can't fill the room with people. It's like there's a complete lack of interest in it. Manual J, unless you're doing new work, it's not required anymore for replacement work. So the last manual J course we tried to do down here, nobody signed up. I think I had 3 people sign up.
Wow.
That's a damn shame.
Yeah.
That says volumes about our industry. Don't tell me you care about people's comfort. Don't start telling me that song and dance unless you're doing the dance. You do the calculations. You follow the codes, the whole 9 yards. You're not just trying to make money. You're trying to make people comfortable. That's what our industry does.
Yep, for sure. All right, Jack, well, it's been an hour. I think I could probably go on for 3 or 4 hours, but I want to get you back on because I think we've only done about the first, 20 pages of your book so far.
Yeah, I'm long-winded.
There's a lot more to cover. So if you'd be willing, I'd like to have you come on again, and maybe sometime I can hire you to come out we have a training room out here in Claremont. We're on the west side of Orlando, so probably about, from where you are, I would imagine it's probably about an hour and a half or so.
I'd be happy. I'd be happy.
Yeah, I'd like to get you out sometime.
Anytime I can help you with these podcasts or you want me to do some training with you, that's how I feed my bulldog. I mean, I don't charge you anything for something like this. An hour or so here and there is not going to kill me. But yeah, I'd be very happy to. There's nothing I enjoy more than talking to interested people about what I've done all my life, this industry.
Real quick, though, let me ask this. So for people who want to hear more about you, who maybe want to possibly hire you or want to know more about your books or whatever, what's the best way for them to do that?
Probably my website, www.jackrisehvac.com. Pretty straightforward.
Got it. So yeah, if you're interested in Jack and what he does, and I would definitely suggest that you get his book on Manual D. It's an excellent resource, and I'll link that in the show notes and everything so that all of you can find that and pick that up. Because I think along with Manual D itself, which is a excellent read too.
Oh yeah.
Definitely much more on an engineering side of things, but definitely worth reading. And then obviously, most of us as contractors are going to be doing the yeoman's work of Manual J, Manual D, Manual S within software. But it's really good to have read the book, to understand it, to really know what you're doing, because there's a lot of cases where it's not that you're necessarily designing a system, you may be diagnosing a system. You may be looking at a system that's already there and wanting to understand what's going on. And a computer program's not necessarily going to help you with that side of it. So it's good to know this stuff.
Yep.
All right. Well, thank you, Jack. I really do appreciate it. All right. So the book is Understanding Manual D, a companion guide to Manual D. I suggest that you go out and get it right away. At least have one for your entire organization. Whoever's doing your duct designs really needs to know this, and then also dig into Manual D itself. I know most of us use some sort of computer assistant, some sort of program to do this, but for a technician, for a technical understanding of manual D and how it functions, or even to diagnose a duct system, Jack Rise's book, Understanding Manual D, is a great place to start. So thank you so much to Jack for coming on. Thank you to all the listeners, everybody who listens to the podcast, everybody who's been saying such nice things recently. I really do appreciate it. Tell your friends in the industry, distributors, technicians, let them know that we're out here and that we're only going to keep doing more. I've been working on some written resources that I think you're really going to like. We're working on a course that's going to be a free course you can go through online just to kind of cover the basics for technicians who maybe never really got the basics very sound. We're going to be doing that. I'm working on a lot of really in-depth illustrations that I hope to put together sometime in a handout that covers a lot of the commonly misunderstood topics, at least in the HVACR industry. And I want to say once again that I don't hold myself out there as being a expert in the true sense. I mean, I've done this for 16, 17 years, something like that, and I'm learning every single day. This HVAC school experiment is all about us learning together, about learning new things, exploring, and really remembering what it is that we like about this trade in the first place. Because frankly, guys and ladies, this is a fantastic trade as far as the interest of the work. I mean, this is really science that we're doing every day, and there's a lot of joy in understanding what it is that we do. No matter how long you've done it, you can always learn something new. So thank you for coming along on this journey with me. We will see you, or hear you, or you'll hear me next time on HVAC School.
Well, I mean, what's not to love? It's my life. Winning.